Okay, this is our first video in statics, and we need to talk about the types of forces that we're going to encounter. So what you need to do is label these types of forces in your notebook, and you need to make a table, and these need to be your 4 column headings: forces, label, description, and direction. You need to do a nice job on taking all these notes down because not only will this show up on quizzes and tests later, but you're going to literally use this on everything we're going to do for the next several sections of this. So you need this information. If you've already had physics, a lot of this may seem very familiar to you. Please write it down anyway. And I will be checking for this and checking that it is all complete when I do a notebook grade check this 6 weeks. So our first one is gravity. And the symbol for it is F for force, and then a little subscript here of a G for gravity. And it's caused by the mass of the Earth. The mass of the Earth pulls on whatever item we're talking about. And for our information, if we know the mass of the item, the force is just M times G. And we will be using that later on. And for our purposes, we generally draw our things where we're using gravity going down, but technically it's going toward the center of the Earth. Okay, our next one is the normal force. If I have a book, for instance, sitting on a table, and all I had acting on it was gravity, that book would literally fall through the table. The reason it doesn't fall through the table is there's a normal force of the table pushing back up on the book. The symbol for it is either Fn for normal or F with a little perpendicular sign. Remember that from geometry. And this is caused by the surface, for example, the table, pushing up on the book. And it's perpendicular to the surface and away from the surface. So in the case of a table, it would be perpendicular to the table and facing up. And the word normal does refer to something that is perpendicular. That's why this can also be the symbol right here. Okay, frictional force. It's either F with a F for it or F with a mu symbol. This is a mu right here. And we use this because the coefficient of friction, when you start calculating it later, uses the mu. You can use either one of these. I don't care which one you use, but you will see this one when you move on to engineering in college. So it's not a bad thing for you to get used to seeing this one now. And it's caused by the surface roughness. Think about it, if something is very slick like ice, there's no roughness to the surface, so there's very little friction. As compared to, say, something like carpet, where the surface is very rough, that causes you to have more friction there. The frictional force is always parallel to the surface, but in the opposite direction of the motion. So if you're going to the right, friction is going to the left. Tension, Ft, and it's something that's inside the member. So like this is a member, it's a little piece here, and tension is inside here, and it happens when there's a pull on both ends. So both ends are going out, and that causes tension here in the middle. And the direction of it is outward from the center. The opposite of that is compression, Fc. It's inside a member here when there's a push going in on both sides, and it's always in toward the center. This one is a general category. We call it an applied force. It's a push or a pull, but it could be almost anything else this is some kind of force that we're telling you is happening. Could be Fa for applied force, or we could call it F push or F pull, something like that, with some kind of descriptive word here describing this. And it's something outside, it's some outside force acting on an object. And it's always in the direction of whatever the force is that it's telling us is happening. Air resistance, Fr for air resistance. Sometimes you also might see F air here. And it's the resistance to movement in air. And if you think about it, if you've ever run into a wind that's pushing on you, it's the opposite direction of the motion. For our purposes, most of what we'll do does not have air resistance in it, but we will have a couple of problems just to practice how air resistance works. Remember, it's the opposite of the direction of the motion. And finally, we have a spring force. Fsp for spring, or Fk. The reason we use the K here is in order to find the force of a spring, K is the spring constant and X is just the distance that you stretch it. You may remember that you've seen this formula either in physics or even in Algebra 1 usually goes over this. And it's caused by a spring, and it's in the direction of the spring. Okay, that's it for this part. Be sure you've got all these notes down in your notebook.